Welcome to my channel. Hello everyone, I am Dishaya, currently pursuing in third semester of BTech Electronics and Communication in Sri Venkateshwara College of Engineering. Subject Network Analysis. Subject Code BEC 304. Section BrahMos. Topic Nodal Analysis. Nodal analysis with two examples. Introduction to network nodal analysis. Nodal analysis is a method is used in an electrical engineering to determine the voltage across each node in a circuit. Nodal analysis is used in a Kirchhoff current law, whereas mesh analysis has been used for Kirchhoff voltage law. In mesh analysis, we'll find unknown current. In nodal analysis, we'll find unknown voltage across the circuit. This technique is particularly useful for analyzing complex circuits with multiple components. By applying a Kirchhoff current law, we can synthetically solve for unknown voltages. Nodal analysis is being used to determine the voltage across the unknown node. In Kirchhoff current law, whereas Kirchhoff current law applied only to obtain linear equation. These linear equations are then solved to obtain node voltages. Linear equations are obtained to solve the node voltages across the circuit. In these circuits, two nodes are there, where N1 and N2. In this circuit, we can apply Kirchhoff current law to find the nodal analysis. Then, key concepts of nodal analysis. In nodal, the circuit can have more number of nodes. A node is in any point in a circuit where two or more components meet. Components like resistance, current, and voltages. The reference node, also known as ground, the point where voltage is defined as 0. A circuit can be connected to ground where the ground does not have a voltage and it will be in 0 at the ground. Nodal analysis includes setting up equation based on a current flowing into and out of each node. In this nodal analysis, we will be using Kirchhoff current law, whereas the equations is based on positive to negative. The flowing of a current in the circuit will be calculated. Then the steps to calculate the nodal analysis. First, we have to identify how many nodes are there in circuit. and we have to design one of them as a reference node. Here we have three nodes, n1, n2 and n3. And then we have to apply KVL equations for each unknown reference nodes in a circuit. Then we have to solve the equations for unknown node voltages. In nodal analysis, we will be calculating voltages of each node of each circuits. Example circuit 1 overview. In this circuit, we have resistance parallel to each other R1 and R2, resistance series to each other R1 and R2, whereas R1 and R2 will be calculated as an add, and uh, and uh, mm, and then it will be calculated as an parallel to each other. Consider a simple circuit with three nodes, including voltage source and resistors. The circuit consists of an voltage source connected to two resistors in parallel arrangement, as I told previously. We will be analyzing this circuit to find the voltages at each node using nodal analysis. Example 1. Nodal analysis setup. Example 1. Node 1 is connected to voltage source, whereas node 2 is connected to reference and node 3 is connected to output node, where we have to write KVL equations for node 3. And this nodal analysis can be expressed in a current in terms of node voltages and resistance using Ohm's law. In this circuit, we have three nodes, N1, N2 and N3. Here, 3 volts minus 2 current of I1 minus of 3 into I1 minus I2. We'll be having equations as KVL rule. As of this, we'll be applying to other two nodes and we'll be getting final answer as 2 volts. In this ground, we will be having 0 volts. Solving the equation. Then we have to solve the equations. Substituting the expression for the current from the KVL equation into a single equation. Rearranging and solving for voltage at node 3. After computations, we find that voltage at node 3 is 5 volts. KVL equations. In node 1, we have IVS minus IA, which is equals to 0. In node 2, we have IA minus IB minus IC, which is equals to 0. Node 3, IB plus IS, which is equals to 0. And node 4, IC minus IS minus which is equals to 0. Here we will be finding IA, IB, and IC values for this circuit. Example of circuit to overview. Now we will be analyzing a more complex circuit with multiple nodes, resistors, and a current source. The current includes three resistors and a current source connected to the nodes. We aim to determine the voltage at each of the nodes using nodal analysis. Example 2. Nodal analysis setup. Node A, Node B, and Node C. In this circuit, we'll be having three nodes as of Node A, Node B, and Node C. We have to apply KVL, KVL rule to find the final answers. Mm. Node V1 will be considering as V1 as node. Vs minus V1 by Ra plus minus V1 by Rb plus V2 minus V1 by Rc plus Is, which is equals to 0. In node 2, V1 minus V2 by Rc plus minus V2 by Rd plus V3 minus V2 by Re, which is equals to 0. In node V3, we have V2 minus V3 by Re plus minus V3 by Rf, which is equals to Is. In this circuit, we have to find out V1, V2 and V3. As of now, we don't have any values. We have written the equations. And solving the equations. And then how we have to solve the equations of nodal analysis. Substituting the current expressions based on node voltages and resistance into an KVL equations. Solve the resulting equation simultaneously to find the voltage at node A and node C, and we have to calculate V1 and V2 at end. Writing a KVL equations for a circuit. Here we have to write KVL equations as we have two nodes, node A and node B. In node A, voltage is also there and current is flowing across the resistance, and whereas in these circuits ground is also there. In ground we don't have any voltages, there we will be having 0. And in node A, I1 minus I2 minus I3, which is equals to 0. In node B, I3 minus I4, which is equals to 0. This is examples of writing a KVL equation. And conclusion and application. Nodal analysis is a powerful tool for analyzing an electrical circuit, especially efficiently. It simplifies the process of solving for unknown voltages, especially in complex network. And understanding a nodal analysis is essential for engineers to design and troubleshoot electrical circuit. In nodal analysis, we will be calculating equations, and in nodal analysis we will be using a KCL equation to find out the answer. In mesh analysis, we'll be using a KVL rule to find out current across the mesh in. That's it. Thank you for watching.